Welcome to video lesson 2.2 underneath Algebra 2. The concept is direct variation, and there are 6 boxes in this video lesson. Okay, box number 1, let's get right into it. What is direct variation? Maybe you've heard this term before, maybe you haven't. It deals with lines and linear relationships, but really all it means is that the ratio of corresponding values is constant. So that's what it means. In mathematical terms, the part that we're going to write down is that the relationship between y and x is y is equal to some constant times x, or y is equal to kx. Or another way that you can write this down is you could say that k is equal to y divided by x. So both of these are mathematically equivalent statements, and all it says is that the ratio of x and y is a constant. That's what it means up here. The ratio of x and y is a constant. So this is what this lesson focuses around, and we'll be doing some examples to get us through this. Okay, here's box number 2. It says, how can you identify direct variation from a table? So I have 2 tables here. I have table A and I have table B. So if we're looking for direct variation, remember you guys that we are looking for the y is equal to kx, or equivalently, we could say k is equal to y divided by x. So if we look at the ratio of the y value to the x value, it always must be the same thing. So that's what I'm going to do. I'm going to take a look at all of the ratios between my corresponding x and y values. So if I take 2 divided by 1, and if I take 6 divided by 3, and if I take 8 divided by 4, notice I get a value of 2, I get a value of 2, and I get a value of 2. Since they are all the same each exact time, it tells me that this table is in direct variation. And the number 2 is a special thing. It's called the constant of variation. Let's take a look at this table in part B. So if I do the ratio of y to x, so 4 divided by 1, 8 divided by 2, and 11 divided by 3. 4 divided by 1 is the number 4, 8 divided by 2 is the number 4, but 11 divided by 3 is not the number 4. So table B is not in direct variation. And that's how you can tell if a table is in direct variation or not. The ratio of y to x must always be constant, which is known as the constant of variation. Okay, here's box number 3. We want to learn how to identify direct variation from an equation. So I have 3 different examples for you, and I will choose to use red here. So remember, direct variation always has to look like y is equal to kx. So this is one way that we can check and see. If I solve this equation for y by dividing both sides by 3, I would get y is equal to 7/3 x, where 7/3 is acting like the k. So since it is in the form of y equals kx, then I would say that this is, yes, direct variation. Let's do the same trick for part B. If I divide everything by 7 here, divide everything by 7, divide by 7, I would get y is equal to 14 divided by 7 is 2x, and then plus the number 1. Well, this does not look like y equals kx, so therefore it is not direct variation. So this is not direct variation because it does not have the form y equals kx. What about this one over here? It says y is equal to x over 9. So it looks like it's not in direct variation, but if you think about it, I could write this as y equals to 1/9 of x. That's the equivalent statement of x over 9. So therefore, the 1/9 is acting like the k, or the constant of variation. So part C is, yes, it is indeed direct variation. So that's how you can check to see from an equation. Okay, box number 4 is an example. It says, suppose that y varies directly with x, and you know that y is equal to 9 when x is equal to negative 15. What is the value of y when x is equal to 21? Okay, there's a very, very important part that I want you to get out of this. Whenever you see this phrase, y varies directly with x, whenever you see that phrase, you immediately write down, okay, that means that y is equal to k times x. That is the mathematical equivalent statement of y varies directly with x. That's the first thing you have to do. Then, let's plug in what we know. If it says that y is equal to 9 when x is equal to negative 15, then I could say that, well, I know that 9 is equal to some value times k when x is equal to negative 15. So if I solve this for k really quickly, if I solve this for k by dividing both sides by negative 15, I could see that k is worth negative 9 over 15. Of course, we could simplify that if we wanted to, but we don't have to at this point. because we want to know what is the value of y when x is 21. So now that I know that k is equal to negative 9/15, I can say that y must be negative 9/15 times x. And if x is a value of 21, then y is going to be negative 9/15 times the number 21. And all I have to do is plug this into my calculator. So I do negative 9 times the value of 21, get that answer, and then divide by 15, and I'm getting negative 12.6. So the first part is to recognize that this is the equivalent statement of y varies directly with x. Solve for your constant k, plug it back in, and solve for the remaining values. Okay, here's a UTRA, box number 5. You have to do this one all on your own and get the right answer in the video. So suppose y varies directly with x, and y is equal to 15 when x is equal to 3. What is y when x is equal to 12? Good luck. Okay, hopefully you got the right answer. If not, here's a quick summary. First, you write down that y is equal to kx, and you solve and you get that k is equal to 5. Then you rewrite a new statement by saying y is equal to 5x with your new constant of variation. Plug in the value that you know of k of equal to, or x equal to 12. Therefore, multiply 5 and 12 and you get y is the value of 60. Okay, box number 6, final box for the lesson. I have 4 graphs here for you. I just want you to look at these 4 graphs and write down anything that you notice or anything that you see. Some of them are direct variation and some of them are not. So I want you to see if you can figure out anything for yourself before I give you the answers here. Okay, so 3 of these graphs are direct variation. Hopefully you recognize that A, B, and C are all direct variation. How could this possibly be true? Well, you'll notice that when you're looking at a graph for direct variation, something very specific has to happen. And that thing is that it has to pass through the origin at the point 0, 0. So you'll notice that in graphs A, B, and C, all 3 of those graphs pass through the origin, but yet in graph D, the equation y equals 2x plus 3 does not pass through the origin. So therefore, graph D is the only one that is not direct variation. You'll notice that A, B, and C are.